square roots we could not use for this problem. So I can only use a square root if I just have an x squared, or if there's a parenthesis and it's squared. If that's not the case, then I cannot use square roots. So factoring, I would check first to see if a problem is factorable. If a problem is factorable, then that's probably the easiest way to solve. Except we have to do something with this first before we can really decide if it's factorable. Nina, what do you have to do with it first? Yeah, so we need to set it equal to 0. So Nina, yours says 0 equals?
I did 0 equals 3x squared plus 6x minus 10.
Yeah, there it goes. So 3x squared plus 6x minus 10. So it needs to be equal to 0 first. And it is usually easier to work with the x squared being a positive x squared. So if you have a negative x squared, if you can move that to make it a positive x squared, it's easier to work with a positive x squared term. So if I want to check to see if it's factorable, we need to take 3 times negative 10, which is negative 30, and then decide, are there any values that multiply to be negative 30 that combine to be 6? So, thinking of the values that multiply to be negative 30, I know we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Do any of those values combine to be positive 6 in the middle? No. So then factoring isn't an option. So I cannot use factoring because it's not factorable. So that leaves me with completing the square or using the quadratic formula. I would only complete the square if I could divide each one of those by 3. If I can't divide all of them by 3 and get rid of this 3, because 3 is not a perfect square, then I cannot complete the square. So it's not factorable. I can't divide them by 3, and we cannot use a square root because it has an x squared and an x term. So that leaves us just with the quadratic formula. And yes, the quadratic formula works for all of them, but there are really good times to use it and other times where it's not really necessary to use. So the quadratic formula, just kind of refreshing that from Friday, it needs to be equal to 0, which we are, and then negative b plus or minus the square root of b squared minus 4 times a times c, and then 2 times a on the bottom. So formula is when you plug numbers in. And out pops an answer at the end. So Peter, what number do we get underneath the square root?
6. Oh, I'm the square root.
Yeah, that's a negative there. So 156, and then on the bottom is 6. Peter, is there a perfect square that goes into 156 to break that down? 4 and? 39. And then to break it down, we have a negative 6 plus or minus. 4 becomes a 2, the square root of 39, and then divided by 6. It's like, no, somebody was messing with my board over the weekend. So the last thing we have to do is simplify this. And to simplify it, I need to think of this negative 6 being divided by the 6 on the bottom. Negative 6 divided by 6 is 1. How about a negative 1? And then I also need to think of the 2 being divided by the 6. Both of them are being divided by the bottom number. So 2 divided by 6 is 1/3. And then the square root of 39 can just get written next to it. So that's a good little review for the quadratic formula. Questions? All right, so let's look at the second one. 3x squared plus 7x minus 24 equals 13x. Ava, how would you start that problem? Before you're really deciding which method to use, what do you think you should do? Yeah, let's get this 13 to the other side. So 3x squared minus 6x minus 24 equals 0. So I could try factoring. I cannot use square roots because these two pieces are in the problem, an x squared and an x, so that's not an option. We could use the quadratic formula. We could possibly complete the square. Ava, what do you notice about all three of these numbers? They're all factors of 3. So we can divide them all by 3. And Ava, if you divide by 3, you end up getting
3x, 4x squared minus 2x minus 8.
I am going to use completing the square just to remind you how that works. And I abbreviate completing the square CTS, just for you to get a refresher about how that works. So if I'm using completing the square, the first thing is to take the 8 to the other side. That's the C term. So x squared minus 2x, and then 8 is on the other side. Anybody remember what you do next to complete the square? Chris? Right, so we take the b number, the value in the middle, divide it by 2, and square it. Chris, negative 2 divided by 2 squared is 1. So we add a 1 to complete the square, but don't forget you also have to add a 1 on the other side. This needs to be equivalent. So whatever I'm doing to one side, I have to do the same thing to the other. And then, Chris, what do you do next? So what do you do with this side of the problem? Right. So this is x minus 1 squared, and he said you square root it. So completing the square, the goal is to get a parentheses squared. That's the goal of completing the square. Can I get a perfect square on the left side? So we square root it. We end up with x minus 1 equals the square root of 9, Chris, is? And also? Plus or minus. Remember, I should have 2 answers for these problems. That plus or minus means I have 2. So one answer would be positive 3 plus 1. And another answer would be a negative 3 plus 1. I could have also found that by factoring. But again, I wanted to remind you of the completing the square process. So quadratic formula is a formula. You plug the numbers in. Completing the square is like a process, a method that you can use to solve. So looking at the one underneath, looking at number 3. We have x squared minus 18x plus 86 equals 0. So I would check factoring first. Are there 2 numbers that multiply to be 86 that combine to be negative 18? So that would be the first thing to check. Josh, are there 2 numbers that multiply to be 86 that combine to be negative 18? No? So there aren't too many factors of 86 to begin with. So then if I say no, I can use the quadratic formula. I can use completing the square again. Either one of those work. Josh, which do you think we could use here? Yeah, let's try completing the square again. Looking at it again another time. Taking the 86 to the other side. So we then take b divided by 2 and square it. So, Josh, I promise I'll only pick on you one more time. Negative 18 divided by 2 squared is? So, b divided by 2 squared? 81. So, we add 81, add 81. And then just like the previous problem, we have to use the square root method now. So we completed the square. Now we're taking the square root of both sides. What happens when you have the square root of negative 5? Chris? Yeah, it's going to be that imaginary number plus or minus in front because that's where we took the square root. And then taking the 9, the plus or minus, and then I square root of 5. So we got to see 2 completing the square problems there. Kind of nice to review that. So how would you solve number 4? Number 4 is different than the other 3. And look to see why would it be different than the other 3. Yeah, there's no regular x. So looking at number 3 and looking at number 4 just has a 3x squared. There isn't an x with it. So Josh, how would you solve this one? Or Nick, I'm sorry, how would you solve it, Nick? So instead of taking the 121 to the other side, we're going to use square roots. And we're just going to get the x by itself. So, Nick, you would take the 13 to the other side. What is 121 minus 13? Say it again. 108. And then what would you do to solve to get x by itself? Divide by 3. Can you take 108 divided by 3? 36. So if I'm using square roots, I want to just get the x squared by itself. So almost like a linear equation, you're trying to isolate the variable. And then the last thing, Nick? Awesome, plus or minus 6. So that's using square roots. So you're isolating the variable, you're taking it to the other side, trying to get it by itself. So looking at number 5, we have negative 5, and then in parentheses, n minus 3 squared, and it's equal to 10. Michael, how do you think you'd solve that one? What do you think you'd do, looking at those 4 methods? Yeah, so dividing by negative 5 leaves us with n minus 3 squared equals negative 2, and then what did you do, Michael? Yeah. So again, this is another problem where we can just use square roots. So he said he's square rooted both sides. So 3. Michael, what happens when you have the square root of negative 2? Awesome. The imaginary number, and then we have the square root of 2. So your answer should be a 3, then the plus or minus, the imaginary number, square root of 2. Questions? So Peter, what would you do to start the last problem? Make it equal 0, yeah. How would you make it equal 0? Perfect. So let's do the subtracting 17t and adding 9. Again, just to keep it positive on that side. So we have a positive 16t squared. Peter, negative 7 minus 17 is? So we set it equal to 0. And most of them were setting it equal to 0, getting everything on one side. Except for the 2 problems where we're using square roots. Alright, so if you look at the problem, is there anything special about the numbers in the problem? Josh? Yeah, A and C are perfect squares. So how could you solve the problem? What would you use? Yeah, we can just use factoring. So this is my A squared 2ab and b squared. That's a trinomial perfect square. We can just factor it. So how would you factor it, Josh? So 4t minus 3, taking the square root of 16, the square root of 9. Both of those are perfect squares. So just factoring the problem. I don't have to do any other fancy thing to get anything to become a perfect square because they already are perfect squares. So when I solve for this, Josh, my answer would be t equals 3/4. Nice job. Questions? So those, yeah, Nina.
Wait, so why would it be like a minus?
Why would it be, oh, because this sign right here is minus. So if this is minus, it's a minus. If that one's plus, it's a plus. The only way I can get a negative in the middle is having a negative in the middle of my factor. So, a little review there of the methods that we've been solving really over the past 2.5 weeks. So I have a review worksheet. The first 4 problems you don't have to solve, you're just choosing a method and kind of explaining why. The answers are on the back. You have 15 minutes in class. So the answers are already copied on the back for you. The quiz tomorrow is 35 points. It's just front back, so it's not stapled, it's just front back. So the first 4 problems determine the best method used to solve and explain why. But you don't actually have to solve those first 4 problems. You're just choosing a method and explaining why you're choosing that method. And then the next group of problems is where you're solving those problems. The last group of problems are more simplifying. So the simplifying that we did with the eyes or the square roots. So use the 15 minutes, get some of this done, check your answers. Please ask questions. We'll have a little bit of time tomorrow to go over a problem or two at the beginning of class.